Yesterday we were introduced to functions, and today we're going to specifically look at how do you know if something is a function or not. So let's go over what a function is. A function relates an input to an output, and we know the input is the x, which is also known as the domain, and the output is the y, which is the range. Very good. Now, for every input, there can only be one output. So we only care about the x's, yes? Now, when you're talking about functions, a function can be written as y equals mx plus b or whatever. But it's very common to refer to them as f of x or g of x. It's just a way to label a function. Okay, so like if we're graphing functions, I might want to call one g of x and one f of x so that I can compare them and I know which one I'm talking about. Because if I call both of them y equals, then you don't know which one I'm talking about. Does that make sense? So we kind of like to label them with different letters of the alphabet. F of x is the most popular one, and you're going to hear this all the way from Algebra 2 to calculus and trigonometry. Okay, so you'll hear f of x, g of x, a of x. It is just a way to label a function, like name it. Okay, so this is the function name, f of x, and then over here is what you're going to get as the output. To identify a function, all you have to do is make sure that no x repeats itself. That's all you care about. On a graph, they can be crazy squiggly lines. They can be lots of different things. The only thing you care about is what? The x doesn't repeat. Okay? So we're going to look at ordered pairs. We're going to look at tables, mapping diagrams, and graphs. And your goal today is just going to be able to say, yes, it's a function, or no, it's not. So in ordered pairs, all you have to do is look at the x's. So highlight the x's. So real quick, sorry. Everybody knows an ordered pair is an x, comma, y. Yes? So in an ordered pair, you're going to look at the x values. So highlight your x values. And if none of them repeat, it is a function. So did any of these repeat? -1, +1. Are those the same? No, guys. -1 is totally a different number than +1. 2, 3, 4. Nothing repeated. So yes, this is a function. Okay, let's go across to this one. Highlight the x's. Did anything repeat?
Yes.
What repeated? So was this one a function? No, not a function. Okay, let's go to this one right here. I'm going to highlight 2, 3, 4, 5, 6. Did anything repeat? Did anything repeat? No. So yes, this is a function. Now, a lot of students get confused because the y's repeat, but we do not care about the y's. We don't care about the outputs. We only care about the x's, the inputs. All right, this one. Did anything repeat? So this is no, not a function. This is super, super easy. All right, go down to the tables. For the tables, it's pretty easy because you're really just looking at the x column or the input column. So go highlight the input columns. You do not care about the y's, the outputs. As long as the inputs do not repeat, you're good. So this one, did anything repeat? So this is a function. Okay, over here, what repeated? These 4's repeat, so this is no, not a function. Over here, nothing repeated, so function. And over here, what repeated? The 2, so this is no, not a function. Okay, let's go to mapping diagrams. We talked about mapping diagrams yesterday. Mapping diagrams are fancy ways of making a table or some ordered pairs, okay? what I would like for you to do, unless you want to go write all of these as coordinates, which would take a long time, what I would do is highlight the X oval. So for all of them, highlight the X oval. That's the only one that you care about. Yes? I like to cover up the output oval, and I like to ask myself, does every single number on the input oval only have one line coming out of it? Yes or no? So this is a function because every X only has one Y. Does it matter that this over here has two lines coming to it? No, that means the Y repeated. It does not mean the X repeated. So over here, if there's only one line coming out, it's a function. So let's look at this one. Cover this up. Does every one of these only have one line coming out? No. What's wrong? This 0 is repeating itself. So if I was to write this, this would be 0, comma, -2 and 0, comma, 1. Therefore, the X's are repeating. So this is no, not a function. Okay, over here, is this a function? Yes. So yes, this is a function. And over here, what's going on? The -9 has two lines coming out, which means -9 has two outputs. So this is no, not a function. Do you have any questions over mapping diagrams, ordered pairs, or anything? What are you only going to look at? Okay, so now let's go to graphs. Now, there's two ways to do graphs. The first way you could do it is you could go list all the coordinates for the graph. That is a lot of work. Do y'all agree? Or you could perform what is called the vertical line test. And I am going to explain this to you by drawing you a picture. So you don't have to do anything yet except just watch with me. So if you have, where'd my pen go? Oh, here it is. If you have a graph, and let's say you have a graph that looks like this. Okay? Everybody see this? So let's say this is -1, -2, -3, -4. Right here at -2, there is a dot up here and down here. Do y'all agree? So if I was to write ordered pairs for this, this would be -2, positive, I don't know, whatever this is, let's say 3. And this would be -2, -3. Do you see that the X's repeated themselves? So basically, if you are to draw a vertical line, do y'all know what a vertical line is? Straight up and down. And it touches in more than one spot, like this, then it's not a function because those X's would repeat like this. Okay? Does that make sense? Okay. It's called the vertical line test. So on this graph, now again, you're only looking at the picture, not the x-axis and the y-axis and the grid. So you're just looking at this line right here. If I was to draw a vertical line, how many times would it touch this picture? Once. That means the X did not repeat. And you can draw another vertical line. Every vertical line that you draw can only touch one time. So is this a function? Yes, this is. Okay, on the next graph, I'm looking at this picture. If I was to draw a vertical line, how many times is it going to touch? So is this a function? No. What's the real reason? The X would repeat itself. Yes? So this is no. Now, what about this picture? Can it be two separate things? Yes, it can. The only rule is what? No X can repeat itself. So I'm looking at this and this. So if I draw a vertical line anywhere, right here, how many times did it touch? Once. I'm going to draw another one. How many times did it touch? Once. I'm going to come over here. How many times did it touch? Once. Over here, how many times did it touch? Once. So did this meet the rule that no x is going to repeat itself? Yes, this is a function. Functions can be really crazy looking. Okay, they can be squiggly lines, they can be lots of different things. The only thing that matters is no x can repeat itself. Okay, let's look at this one. This is the picture I'm looking at. If I was to draw a vertical line, how many times does it touch? Once. Do another one. How many times did it touch? Once. Over here, how many times? So is this a function? Yes. Okay, let's do the next one. How many times is it going to touch? Once. Once here, once here. I could keep going. It's only going to touch once. So yes, this is a function. Okay, over here, how many times is it going to touch? Twice. Right here and right here. So no, that's not a function. Okay, turn the page. We're almost done. It says, use the given form of each relation to complete the other forms, then determine if it's a function. So they want you to take this mapping diagram and make a graph over here. So here we go. I'm going to go to -1, -2. So here's -1, -2 right there. Are y'all with me? Now I'm going to go to 1 on the x-axis and then down to -1. And then I'm going to go to 1 on the x-axis and I'm going to stay at 0, which is right here. And then I'm going to go to 2, 2, which is here, and 3, 2, which is here. Looking at the mapping diagram, is this a function? Why? Because the 1 is going to... Now, if I was to draw a vertical line, look right here. How many dots did it touch? Twice. So either way, it doesn't work. Is this a function? No. Now they want you to take a graph and make a mapping diagram. Okay, so I'm just going to start with this point. This point is at 1, 1. Okay, this point is at 0, -2. This point is at -1, 1. Are y'all okay? This point is at -2, 0. And -2, -3. So do you see how the -2 has 2 lines coming out of it? Also, if I was to draw a vertical line right here, how many times would it touch? 2 dots. So no, this is not a function. Okay, moving on. Rewrite this table as a mapping diagram. Okay, so I've got 1 going to -2. I've got -3 going to -1. What do I have here? I already wrote a 1 though, right? But it needs to go to 0, so I'm going to put a 0 here and put that 1 also is going to go to 0. 2 is going to go to 2, which I don't have those yet. And 0 is going to go to 3, and I don't have either of those. Was this a function? Why? What repeated? The ones. Okay, they want us to take this graph and rewrite it as a set of ordered pairs. What does it say? Not a table. They want you to write it as ordered pairs. So here we go. I'm going to start with this one. Where is this ordered pair at? On the x-axis, it's at 1. On the y-axis, it's at -1. Okay, now I'm going to come to this one. On the x-axis, I'm at 0. On the y-axis, I'm at 2. Right here, on the x-axis, I'm at -1. On the y-axis, I'm at +1. Right here, on the x-axis, I'm at -2. On the y-axis, I'm at -3. And this last one, on the x-axis, I'm where? Guys, on the x-axis, I'm where? -3. On the y-axis, I'm at 0. Is this a function? Why? Because none of these x's repeat, and if I do a vertical line test, it only touches one time. On this last one, we're not going to do this part where it says identify the domain and range. That's another lesson. But we are going to say if it's a function or not. So everybody look at this one. Is this a function? Why? If I draw a vertical line, it's only going to touch once. So yes. Is this a function? Why? It's going to touch twice if I draw that vertical line. How about this one? Yes. Now, just looking into probably, I think it's tomorrow's lesson. I just want y'all to kind of look. We are going to learn how to identify the domain and range on these graphs, and that's the hardest part of functions, okay? Because you're going to have to make inequalities out of them. So if you look, this x can go anywhere from -2 to what? To +2 on the x-axis. Then you're going to have to make the range, which it can go anywhere from -2 on the y-axis to, and I have no idea what that says, 1 on the y-axis. So we're going to be making inequalities out of those. So let's just look into the future. I'm going to pass out your assignment so that you can get. The assignment's pretty self-explanatory. Just make sure you read the questions carefully. Like number 1 says which one is a function, but number 2 says which one is not. So be careful with the way you read. Just to mention, if you look at number 4, letter D, do y'all see this open dot over this closed dot? The open dot means it's not a dot. It doesn't belong there. So if I was to draw a vertical line, it's not touching right there. An open dot, y'all remember what we learned when we graphed inequalities like this? That means it doesn't, like this point really doesn't exist. You see what I'm saying? Okay, so if it's a closed dot, it is a point. If it's an open dot, it's really not. Okay? Let me see if there's anything else I needed to explain.
What does it mean by y as a function of it?
Is it a function? On the very last page, right here, it's a cut and paste, but I'm not going to make you cut it out and paste it. The answers are on the back. What I want you to do is list them. Or actually, you know what? Even better, don't do this page. Go to the back side right here, and you're just going to write yes or no if it's a function. Okay? Everybody hear me? So just go through these pictures and write yes or no if it's a function. All right, get busy.